Okay, in this video we are going to be looking at the dangers and uses of electromagnetic waves. Make sure you watch the introduction to electromagnetic waves first. So we are going to start with our smallest frequency waves, and they are radio waves. The main use of radio waves is communications. Long wave radio waves can be transmitted and received halfway around the world. That's because these long wavelengths allow the waves to be diffracted. That basically just means that they can bend around hills, tunnels, buildings, and around the curved earth. That means a receiver can receive a wave even if the transmitter isn't directly in line with the receiver. Shortwave radio are not diffracted as well, but they can still be received at large distances between the transmitter and the receiver. They use parts of the Earth's atmosphere, the ionosphere, to reflect waves back down to Earth. An example of something that uses shortwave radio is any Bluetooth device, like my AirPods. I don't know if you've ever tried it, but you can actually get quite surprising distances away from your phone without any interruption to your Harry Styles bangers. Radio waves that are used for TV or FM radio have quite short wavelengths. So in order to get reception, you need to be in sight of the transmitter. That's why you'll often see those TV aerials on the tops of chimneys. Okay, now bridging the gap between radio and microwaves, we have satellite communications. This is where a transmitter on Earth sends a wave out to a satellite in space. The satellite in space then transmits a wave back down to Earth to the receiver. Used for satellite TV, satellite phones and internet, and military communications. Those satellites must hold a lot of secrets. So we either use high frequency radio waves or microwaves. These waves can easily pass through the Earth's atmosphere without being diffracted, reflected or refracted. So they can reach the satellites easily. Another use of my microwaves is cooking. Speaking of which, I've just made myself a delicious little treat in the microwave. I don't know how well you can see that, but it is a microwave mug cake. And yeah, it is only 10:30 in the morning. I'm not sorry. So, microwaves are absorbed by water molecules in food and transfer the energy to thermal energy of the water molecules. The water molecules heat up and then they transfer that energy to the other molecules in the food until it's cooked. This means you can cook food really quickly, like a cake in 40 seconds. However, there is some debate as to whether this property is also a bit dangerous, because since cells in your body contain a lot of water, the microwaves can cause those to heat up too. Jury's still out on how harmful this actually is. Next wave on our spectrum, infrared. These can be used for thermal imaging. You can see heat loss through different parts of, say, a house. They can be used in security cameras. A person gives off a lot of infrared radiation, so an intruder can be detected. Cooking, infrared causes things to get hotter. Heating elements on toasters use infrared radiation. Speaking of which, no, I'm joking, I don't need toast and a cake this morning. And again, for communications, infrared signals are used in optical fibres. They can carry data across very long distances. Also, an important one here, TV remotes, because who wants to get up off their sofa to change a TV channel? However, infrared radiation can lead to burns because of its heating effect if it is absorbed by your skin. Luckily, most infrared radiation is reflected. Okay, next on our list, visible light, which we use to see, but is also used in photography. Visible light is detected by digital cameras and converted into electrical signals to give you your photograph. Our next electromagnetic wave is UV. UV can be used in security, and it takes advantage of a property called fluorescence. When UV is absorbed by fluorescent materials, those materials then re-emit waves in the form of visible light waves. So, for example, you could mark a particular banknote with a fluorescent pen, and then usually that marking would just be invisible to the naked eye. But if you then shone a UV lamp onto your banknote, that fluorescent pen would absorb that UV and re-emit it as visible light. So you'd see whatever invisible marking you had put onto your banknote. In fact, banknotes do have this, and it makes it more difficult to forge your own banknotes. UV can also be used to disinfect water because it has enough energy to damage and kill cells. It can also kill bacteria in water. But beware, UV radiation can be absorbed by the skin. It's ionizing radiation and it can cause cells in your skin to mutate, which could develop into skin cancer. It can also damage cells in your eyes, which can eventually lead to blindness. So make sure you've always got your sun cream. That's a complete waste of sun cream because I'm literally filming this in February. Okay, on to X-rays. Now we all know that X-rays can be used for medical imaging, but how it actually works is your X-ray film begins clear. And X-rays are really good at penetrating soft things like flesh, but they are absorbed by more dense materials like bone. Your X-rays are sent through somebody's body, and those that make it all the way through hit the clear screen and darken it. Those bits of your body that are bone absorb those X-rays and leave those parts of the X-ray clear. So then you can build up an image. Sometimes X-rays are also used in airport security to detect some hidden objects. Well, it's quicker than opening everybody's bag and having a good rummage through. However, X-rays are also ionizing and therefore can also cause cancer. Sometimes they actually kill cells entirely. This causes radiation sickness, even eventually death. Okay, and finally, gamma rays. These can be used for sterilization, like sterilization of medical equipment, but they can also be used to detect and treat cancer. To detect cancer, somebody will ingest a source which emits gamma rays. Gamma rays emitted from the body can be detected by a detector, and doctors can then use that information to determine if and where any tumours may be. Since ionizing radiation can kill cells, it can also kill cancerous cells. So gamma rays can be directed towards a tumour to kill it. However, just like X-rays, gamma rays can lead to cancers if they are incident on normal cells, radiation poisoning or death. You may have noticed that the higher the energy of radiation, or the smaller the frequency of radiation, the more dangerous the electromagnetic waves are. Okay, hope you found that helpful. Please do like and subscribe. Make sure you download the notes for all of those dangers and uses. Thanks for watching.